Hello, students. Today we will have our second lecture in ergonomics. We will talk about system design, what it is, and why we need to understand it in ergonomics, and what is its relationship to ergonomics. So let us start. Now, a system can be described as a group of interacting or interrelated elements that form a unified whole. Now, a system can never exist on its own. I mean, you cannot say that this, for example, object on its own, alone, okay, without me touching it, is a system. We cannot say that. But also me, I am not a system, I mean, alone, without coming in contact with this object. But once we are in contact, okay, once we are in contact, now, me plus this together, we become a system. So we have to have at least two interacting elements so that we can call this a system. So me interacting with this, we become a system. And we form a unified whole. So we become one, but we are a system, okay? Now, why is this important to understand in ergonomics? Why do we need to know about systems, or if something is a system? Well, because in ergonomics, if you remember, we always have a human and some kind of a relationship with, let's say, a product. So if I'm touching this here now, this is a product, okay? So if I want to cut with it, if I want to do a task, what's a task to do with this? For example, cutting, okay? What's a task to do with this? Again, cutting, but in a different way, okay? So there is always a human and what? A product. And once I touch this product, I want to do something with it. I'm going to perform a task. So systems exist in ergonomics. The ergonomics is based on that. So if we don't understand what are systems, what are its characteristics, what are its types, what are the types, we will have a little bit of difficulty of understanding where we are and how to deal with these items. So we need to have a clear understanding about what are systems and the different types, and what involves, what characteristics, what things are important for the different types of systems, so that we can design products in a successful way. And what does it say here? To improve the interaction between the machine or the product and the user, the human. So there is always this point of contact, okay? So we need to, in ergonomics and in design, of course, we need to focus on the points of contact, okay? This has different points of contact than another object. And when there are points of contact between me and the product, this is called interaction, okay? So to improve this interaction, okay, we need to understand some things in general about systems, how they function, okay, what they are. So in a very basic way, of course. Now look at these images here. There is always, okay, a side, which is the human side, and the machine side. Now don't get confused with the word machine. Machines, this is how they talk in ergonomics. Human, machine, like systems or interactions or these kind of things. But Machine is really the product, okay? Like this is a product. You can call it a machine. This is a machine also, or a product. So when we talk about machines, it's all the products actually that we are coming in contact with. So look at this. There's always a side for the machine and a side for the human. And there is an interaction between these two going on. This is a system, okay? So this is a system. Look at this, the children playing with the toys. They are touching them. They are interacting with the toys. This becomes a system. This is a system. The human hand with the scissor doing a task. Together, they are interacting. They are a system. Human driving a car. This is a system. Okay, now we can categorize systems by the degree of manual versus machine control. What does this mean? So how much of the work, of the job, of the task does the human do, and how much the machine? Sorry, let me explain it in another way. So how much is the task manual, and how much is it automated? Now, if we have simple tools like this, for example, this is a simple tool, this is a simple tool, okay? These are what manual systems. When I start using them, they become, okay, you need to first touch it and start using it, and then you become a system. But these are manual tools and manual systems when I'm using it, because I'm using it by my hand, by my body. This is not a powered tool. So this does not work using electricity, using power. No, it's manual. Okay, I have to use my own strength to use it. Okay, I have to use my own strength to use this. This is not a power tool, no electricity to help me. Okay, so how much is something manual, or how much automated or powered? Okay, this we can categorize systems in this way. So the manual systems consist of these kind of simple hand tools, as you can see from the picture. So you have to use your hand manually, your body, to do the task. So this is a system here, the worker with the tool, manual system. Now, when we talk about mechanical systems, these include powered tools. Like, for example, this mixer in the kitchen, okay? What do you do? When you touch this, what happens? You switch on the button, you press, you switch on, and then who does the work? Who does the work? The machine, because it's powered, it has electricity. So who makes this to go round and round? The power, not you. Now, I have to use, okay, well, it is from a machine, but this one, imagine this is a manual system, okay? So manually, I have to do this, okay? But when we have a powered tool like this, I don't have to do the work. I just switch on the button and I wait. I'm relaxed, okay? And I wait for it to finish. So the requirements for manual systems is very different than mechanical systems. How it affects the human body. You know, when the human uses a power tool, it's different than a manual tool. So this will affect the design. So how do you design a manual tool? It has very different requirements than when you're designing a mechanical system with a powered tool. Each one of them have different design requirements. Now, of course, it depends what kind of tool, what kind of machine you're designing. But in general, the requirements are different. Very different needs here, okay? There is also a third category, which is the fully automated systems. This apply basically to like big manufacturing plants where the human is only used for example, to switch on the machines, and then the machines do all the work. They manufacture whatever is manufactured entirely alone without human involvement. Now, this is almost a fully automated system, almost, because there is still human observation. The human has to observe, switch on, switch off machines, and these kind of things. But the human does very little work compared to the machine. So the machine is dealing with the job, with the task. There is also fully automated systems when they send, like these outside of space, and nobody's controlling them. Like everything is done by the machine alone without human involvement or control. So this is fully automated systems, or almost fully automated systems, like in the manufacturing plants. Now, you as a designer, in your life, when you design, you will rarely come in contact with this. You will rarely be involved in designing fully automated systems. Like here, there is more engineering involved. If there are designers involved, but more engineering oriented. Now, you will be mostly involved with manual system design and mechanical system design. This is what you can get involved with as a designer most of the time. When we talk about products, okay, because these are products. The tools, these kind of machines, they're products, they're considered products. So you as a designer can get involved in these kind of systems. So later on in our course, when we do our projects, one project will be for manual systems and the other project for mechanical systems. So you can try to apply what you learn during our lectures, okay? Now, so these three categories. So first, when you have a product in front of you, you have to decide, what is this? Is this, what kind of a system? Because this will set immediately what kind of basic things you need to think about it. What kind of requirements it has. So is this a manual or a mechanical system? This is the first thing you have to think about, okay? Then you have the relationship, the interaction between the human and this product. If it's a manual tool, it's different than when it's a mechanical machine, for example, okay? So the interaction becomes different. The relationship between the human and the product is different depending on what type of system it is, okay? And you will need to design it using different rules, different requirements, depending on what type of system you're dealing with. Another thing about systems, okay? Why is it important to categorize things into system types? Is because humans have certain strengths and also weaknesses. And machines also have strengths and weaknesses. So, understanding what strengths and weaknesses the human side and the machine side of the system has is crucial. It's very important, okay, to the design of any product. It's very important to decide what is the weaknesses and what are the strengths areas of each of the sides. So that, because as a designer, okay, you identified, for example, this is a manual system or it's a mechanical system. Okay, the next step is to identify what is the strengths and weaknesses of each, so that you know which tasks to give to the human and which tasks to the machine to perform. If you don't know what the human is good at and weak at, and you don't know the machine, what is it good and what is it weak at and strong at, you will not know how to divide the tasks. So should the human do this, or should the machine do this automatically? Which is better? So of course, you're not always free to choose. Sometimes you must design, for example, a manual system, or you must design a powered tool. But this is, let's say, if you had the free choice. And also, you need to know about the requirements of each, okay? So, for example, the humans have certain abilities, okay? They're better than machines, and in some aspects. And in other aspects, they're weaker than machines. And machines have also their strong parts. For example, a computer. The computer as a machine can, for example, calculate much faster than the average human. So if we have, for example, to calculate complicated, long calculations, which needs a lot of careful attention, hours of work, attention to details, so that we don't make a mistake. Now, which is better, to give this task to the human to do, or to the machine, the computer? It's better the computer, because the computer will calculate very fast, much more quickly, very fast, which is much quicker. It will not make mistakes like the human. So the possibility for errors is much lower. The computer does not get tired. Now, if a human has to stay 20 hours calculating, the human will be exhausted. The human needs rest. It's like I work, then I have to rest. Then I go back to work, then I have to rest. If there is no rest, the human mind will stop, functioning. The human mind will stop functioning in its optimal way. So when you have to do long, prolonged tasks, jobs that need hours of work without rest, difficult calculations, for example. So these tasks are better assigned to the machine to do. The human, on the other hand, is weak in these tasks in general, okay? So almost all humans are weak, okay? All humans need rest. This is a fact. So when there is also tasks that need a lot of memory storage. Now, the human mind, everybody can forget. Like, for example, if I have so much information in my head and I hit my head by accident, maybe my memory will all go. Or, for example, I am under stress. And under stress, the information that I have in my head does not come out the same way that when I am relaxed. Now, if I give this lecture, the same lecture today, and I give it tomorrow, or in the same day 2 times, each time I will be talking in a different way. So the information I'm speaking will not be the same. Similar, but not the same. If I'm, for example, under stress today and I'm very tired, the outcome of my lecture will not be as good as when I'm in a better state health-wise. Now, the machine does not have these problems. Okay? The machine functions at all times, at any time, the same way. It's efficient in its work. Now, the humans also have some strong points, though, better than the machine. And here are the things that the human is better than the machine. So for example, the human has more flexibility. The machine is rigid, okay? You give it certain tasks to do, it will do these tasks, but it's not flexible to change as needed. The human can change at any time. I can deal with 5 or 10 things at the same time almost. For example, if now I do something and something else happens, someone comes in and starts talking to me, immediately I change, I start replying, so I'm very flexible, okay? In this way. The machine is more rigid. So there are certain things about the human mind that the machine cannot achieve successfully. Even the most advanced robots they design nowadays, they try to imitate as close as possible the human, but the human design is superior to all of these machines at this level that we are in. Just the things that I mentioned, like routine work, computations, which is the calculations, not getting tired, the speed, these kind of things, the machines are better than the human. And they can do the tasks in a more efficient way. So if you're designing a product, a machine, okay? And let's say it's a mechanical system, okay? So it's a powered machine with a human interacting. You need to decide, okay, what tasks do I give to the machine to do, and what tasks should I give to the human to do? And to know this, you need to be clear. What is this machine you're designing? And what are the strengths and weaknesses of the human and the machine? To decide this. If you don't know about these things that we talked about, your design will not be good. It will have several faults in it. So, as a summary, designers must use ergonomics to study, analyze, and design products and systems that fit with the target user needs to perform tasks, and also to fit with the environment in which the design, the product, whatever, will be used. So, now to study and analyze, we will talk about analysis a little later, okay? But in general, when you design anything, okay, any type of design, ergonomics also has information of how to analyze a design before you design the new design. It's like, okay, I have this product, okay? What is this? A cutter. How does a cutter function? What is its main function to cut, okay? So the tasks that I'm doing with it is mainly cutting. Now, I want to design a new one, okay? Before I sit and start drawing shapes of new cutters and go crazy, okay? Before I do that, I need to analyze the existing cutters. Ergonomics helps me in that. It gives me information how to analyze this, for example, that already exists, so that I can find mistakes in the design. So I can find, okay, where are the mistakes? Where are the problems in this one? So that when I design the new one, I can solve these problems. This is analyzing existing products, existing machines, existing whatever you're designing, and find where are the problem areas. And you as a designer need to fix them, need to solve them in the new design. Remember, design is about problem solving. Design is about what? Problem solving. It is not about creating beautiful objects. I'm not going to design a new cutter and draw some beautiful shapes that have no meaning. Without understanding this, I cannot design a new. Without understanding everything about this product, I cannot design a new one. And the things that I need to understand most of all is, where are the mistakes in this design? Where are the problems? We are not designing just for fun. Your job as a designer is to solve problems, solve as many problems as possible in our world. So if I'm sitting on this chair now, and it's not comfortable, it's not comfortable, okay? I have to go, before I design a new chair, see what other chairs are out there in the market, what other chairs are designed, analyze them all, extract the problem areas, the mistakes in the designs of all, collect, then sit and think, okay, how can I solve these problems? And come up with a new design that is better than what's available now. Okay, so design is mainly about solving problems. If you cannot solve problems, well, you will not be a designer. You can't be a designer. And ergonomics, okay, with all of these things that we talk about, gives us information. For now, we are just discussing, you know, like in ergonomics in general, systems, whatever. But when we go deeper into ergonomics, you will see that it gives us guidelines, information about how to design, for example, manual systems or mechanical systems. What things do we need to be careful about? How to, for example, analyze a product and find its problems, its design problems. How? Ergonomics gives us such guidelines. And we will see some of them later on when we go a little deeper into the material. Of course, again, we cover only the basics. We don't have a lot of time to go really deep into ergonomics, but it will give you enough knowledge to grasp what is ergonomics all about and how it can help you in design. So, in summary, the relationship between the following aspects must be always strong because, with following aspects, the product, the user, the environment, the tasks, the relationship must be always very strong, very perfect, so that you end up with a successful design. With an ergonomically successful design and a happy user. So, always you have a product, some kind of a product that you're designing. And the user, who is the user that's going to use them? You have tasks. What kind of tasks is the user going to perform with this product? And in what kind of environment will this happen? So all of these four aspects are always connected with each other. You cannot focus on one or two and three and forget the rest. All of them always are interrelated. In any design, you must consider the needs of all. The human is the focus, but the human exists in an environment. And the human is using a certain product. What is this product? What tasks will be performed with this product? Okay? All of this together must be considered for the design to be successful. If you forget any one of them, there will be problems in the final design. So, major benefits of ergonomics in simple words. This is again a summary of the major benefits of ergonomics and in a simple language. So it creates, ergonomics helps us to design safer products and environments, work environments. Most of the time we're doing some kind of a work, okay? So if you're at home in your kitchen and you're working, this is doing something, this is work. I am working right now, okay? In my office in the university. When you're cutting something, you're working, okay? So, but what is the environment? So to create safer products and environments, working environments with fewer injuries. For example, if I'm now in this environment trying to cut something and the light, okay, the light is not good. I cannot see. Well, what does it, what will it do? It will make it unsafe, not safe for me to use this. I cannot see what I'm doing, okay? The lighting is part of the environment. Ergonomics helps us to design products so that we can increase efficiency and productivity. So we can produce, we can be efficient at our work, whatever we are doing. And improve also our quality of life and work with fewer mistakes. And of course, create happy humans while working, okay? While doing tasks. We are doing tasks all day long. Whatever you're doing, at any time you move and you do something, you're working, you're doing tasks. And we need to be happy while doing this. Now, the importance of the designer comes in the design of these products and environments, so that to make the humans, the users of these products, happy and safe. Here we will see a few examples of the things that we talked about, especially these four aspects. So we have user, we have always a product, we have tasks that need to be completed, and all of these happen in a certain environment. So let's see here, what do we have here? Look at this, for example, the space suit, the space suit design, okay? Now, why is it designed in this way? Why is it designed in this manner, with these materials, with this shape, with all of these things? Because the designers had to take into consideration that this spacesuit will be used, will be worn outside of space. So the environment outside of space is different than here. So the suit has to be safe for that environment. There is no oxygen. So if the human was like this going outside of space, you will explode. Okay? So the suit has to protect this, the human in this environment. So it's designed in a special way. Now, if the designers had no knowledge of ergonomics, no knowledge that the product and the human have an interaction and have to fit one another, it would be a problem. It would be a problem. Look at this bicycle here. And this is the human riding a bicycle, okay? But notice the design of the bicycle. Notice the design, notice the wheels. They are very thick and short, not long, not big size, small size and very thick. What's going on here? And look at the design of the bicycle, how broad this is. It's a totally different design that you will see in a city bicycle. The normal bicycles that are used in front of your home by children. That's because the designers understand the relationship between the human, the product, and the task that needs to be performed, which is driving the bicycle in this environment. What is this environment? It's a mountain, rough terrain, mountainous, rough terrain environment. So this bicycle has to be used, it is a mountain bicycle for rough terrain, rough terrain. You see, you have stones, you have up, down. It's not a smooth road. So the bicycle is designed in a way that you can use this in this terrain safely. Now, if you were driving a normal bicycle, a city bicycle in this rough terrain, you will fall down. You will get injured. It's not safe. The design is not safe. So the design has to change according to the environment. And it has to fit with the user's need. So the user has to be comfortable and safe while using the bicycle in this rough terrain environment, and to perform the task successfully. Well, what's the task here? To be able to ride the bicycle around and above the stones and this sand successfully. So the product, the task, the environment, the user. If the designer ignores one of them in this design, it will not be a successful design. Let's see another example. Look at these billboards. These billboards are designed by graphic designers, okay? And they are on the road, outside. What environment? The outside environment. The outside environment has certain characteristics. So the designer had to take this into consideration. For example, what materials to use for this? The materials have to be suitable so that when the billboard stays under the sun, under the rain, under the wind, the outside elements, okay? This material has to basically not get damaged. And even the colors must stay the same. Everything, okay, must be visible. So when the rain comes on this, it shouldn't get damaged. So the designer has to consider this. Where is the human in this design? Well, the human is most likely going to be inside a car driving, and I will be looking. Okay, there is a billboard. What does it say? Okay, so I will be driving and looking. So here is the human element. This billboard has to be designed not only to fit the environment, but also the human that will be looking at it in this environment. So the human is outside, inside a car, outside, driving, so going with a speed, and looking at the billboard. So the designers have to be very careful how this is designed, because when you're driving fast in a car, you do not have opportunity to look a long time and read, what does it say in this billboard? You don't have this opportunity. You must focus on driving. So you have only seconds time to look, okay, and receive the message. Now, if this billboard was designed with fonts, sizes of fonts that are wrong sizes, maybe too much information, maybe the wrong photos, maybe the organization of the billboard is not in a good way. When you drive by fast with your car and you look at it in seconds, you will not receive the message. You will not understand the message. You will miss information, okay? So the designer has to take into consideration the human, this design to fit with the human need in this environment, in whatever the human will be involved in doing. Task. The human is driving a car and looking at the same time, trying to read. So you have a very complex situation. In every design, you have a complicated situation that involves many factors that you need to consider before making design decisions. So that the end result, the design, is useful. Otherwise, it will have a lot of problems. And every design is like this. Look at this, for example, design. This is a handheld device. And look how the buttons are organized so that they reach exactly the fingers, the locations where they should be. So we have a product here. We have a human. We have a mechanical system. It's a mechanical device of some type. So the human the product, this system will exist, will be used in a type of environment, okay, depending on what device this is, and some kind of task will be done with it. So all of these principles, all of these aspects, the 4 aspects, they interrelate with each other always, and the interrelationship, the interaction must always be successful, and this is to be decided by the designer. You as a designer must make all these decisions. How the final, for example, product should be. It's not only about looks. Get out of this mental idea that design is about looks, about the shape. The shape is part of everything. But if it's a beautiful shape, but it doesn't function correct, this is a beautiful shape, but when I put it in my hand, it's not comfortable. I cannot use it. What does that mean? It means that the design is a failure. Okay, so these 4 aspects, always remember them before you design anything. Okay, never forget. Okay, this is enough for today. I will see you in the next lecture when we will discuss anthropometrics, what it is, what its relationship to ergonomics, and why do we need to know about it. Thank you for watching and see you soon.